In this presentation, we're going to consider alternative energy, solar power in particular, and we are going to do a tour of solar installations. In one of our previous sessions, which can be found in part 27 of preparingforthetimeoftrouble.com, we took a look at the basics of understanding how solar power systems work, and the different options for batteries and for being off-grid and grid-tied. But in this case, we are going to visit different installations, and in the process you will see demonstrated the differences between grid-tied and off-grid. And so, just to refresh your memory, grid-tied solar power systems are solar panels which then send direct current power to an inverter. An inverter changes it to alternating current, which can be used in your house or sent back in a two-way meter to the grid. By comparison, an off-grid system has similar components, but it also has a battery bank and a charge controller to manage the charging of the batteries.
Solar perspectives, looking at different types of systems. The first system we'll look at here is a grid tie solar system, and this system is comprised of 14 iTech Energy 240 watt solar panels that are connected together via microinverters. So each panel has its own small inverter system associated with it, and the benefit of that type of a system, particularly in a grid tie situation, is that typically in a non-microinverter system, if you have shade on a panel like you see in the far left in this particular picture, the whole system will be depressed in its production to the low level of the lowest panel. With microinverters, it will compensate and maintain full power output for all those in full sun and maximum output that's possible within the shade for that particular one that's in the shade. So it allows a more constant and complete power output. If a solar array is in complete sunshine, the microinverter advantage is less pronounced because it's in full sun or full shade in a continuous basis versus a pattern basis. So this particular incentive or arrangement that we're looking at here was set up in a grid tie situation so that it's into the main power grid, and it actually has a power production incentive associated with it when it was installed at 36 cents a kilowatt hour that was produced. It also builds power against your account so that it reduces your power bill, and it can bank it on the grid toward your power bill, thus reducing your overall power costs and providing savings. When this particular array was installed, a small loan was taken out through a credit union that actually utilized the panels as the collateral for the loan, which didn't jeopardize anything else in the process of having that take place. So it was actually does show the value of the system and the panels that the credit union would take them as the collateral. And during the course of the incentive program, the panels were completely paid off. So it has no batteries associated with it. So it's completely tied to the power grid. So it does provide solar power and preferentially uses it in your own house. If you need additional power, it draws it from the grid. Any additional power that's not used goes to the grid and is used by your neighbors. The downside is that when the power goes out, your power goes out too because you have no batteries to back it up. So the overall benefit is that it lowers your power bill by offsetting your usage of the grid tie power, as well as a period of time where you actually get paid for the power that you produced at 36 cents a kilowatt hour that you produce from the sunshine. This particular array had that program sunset in 2020, and so that power incentive is no longer present, but the system is already in place. So there are 3.36 kilowatt hours represented here of potential production on this particular grid tie solar array. Another project that I've been a part of is an off-grid pump project. A well that was off-grid, essentially not having power accessible readily to it, was able to be functional by utilizing a DC well pump in a 77-foot deep well. And this particular pump array was providing irrigation to a drip irrigation system in a garden situation and utilized two 100-watt panels as the power source. You can see that it has a period of time during the day where it is in shade. However, it's uniform, so the microinverters are not an issue in this, aside from the fact that it's also using a DC pump, so it's DC current, and you wouldn't need an inverter anyway because that's what converts the power to AC current. So utilizing two auto batteries, you can see in the upper right corner, just barely out of sight there, are the auto batteries as the deep cycle batteries that are the power bank. And then the white box on the lower left is your charge controller. It goes through a power box with breakers. If you have to do any servicing, you would use the breakers to isolate the electrical systems. So the charge controller basically controls the amount of power that charges the battery so that they don't become overcharged when not in use. So it's a small, simple system, but it maintains the head in the pressure tank so that the irrigation system can function appropriately during the daytime and early morning, and then the sun recharges the system so that it keeps it topped off, basically a trickle charger for the battery system. The third system that we'll look at is an off-grid rack system. So you can see here the process of building the racks. The upper left picture shows the three posts offset in height. They'll have extensions that you can see in the right-hand picture that were added to provide it with the proper angle. About a 45-degree angle in our area is optimal for year-round seasonal sun exposure. You can see the gap at the end of the upper left picture had to do a pole extension to offset the change in terrain. So that each of those posts are set in concrete and are made of chain link fence end posts. The diagonals are made of line posts, chain link fence line posts. And we also put in some bracing made of top rail, chain link top rail fencing. The horizontals are made of steel. They're unistrut. And then we utilized a 2x4, 2x6 system below as a panel stabilizer when the panels were installed to slide them into place to keep them from sliding down to the ground while we affix them to the unistrut. Here's the first panel in place. It's put up onto the unistrut with the lower 2x4 shelf system to help keep it in position while the unistrut are attached. So I had to pre-drill or drill in place the holes to attach the cone nuts that would attach the unistrut to the rack system. Basically, they slide back and forth within that unistrut system. So this is going to be comprised of 12 320-watt panels directly south facing, so there's no shading that occurs that is patchy on this system. There's going to be some trimming of the tree there in the upper left to help make sure that that's completely clear for the system. So it's a 3.84 kilowatt hour system, and at this particular site, batteries will be installed at the array along with the inverter and charge controllers, all housed in an area below the rack. It'll provide a nice shading area for the system. The inverter will actually change the power to AC, which travels better across the voltage lines to the house where they'll be implemented. DC power attenuates or decays much quicker than AC power. So that's why the battery array and the inverter system will be housed right at the rack site. So here's the array that is being installed. The lower ledger holds the panels in place while they're being bolted to the unistrut. The upper panels utilize the cardboard you can see below there to shield the panel below as the upper panels are slid up the panel and then hoisted above from the ladder you can see in the background there to the upper section of the panel array. The unistrut is the anchor point for the cone nut that you can see here. That little blue cone helps hold it in the channel, but also isolates it from the aluminum frame, so there's no galvanization that takes place between the different metals of the steel and the aluminum. So here's the lower edge of the panel array again up close, and you can see that it was maintained and positioned by the 2x4s that are holding onto the unistrut above, and you can actually, there's enough distance there that is the ledger that it can hold the panel that is going to the above position as well. So this is how those panels were supported during installment to keep them from sliding out of position on the rack. So here's the panel system near completion. There's 2 more to go, and then additional, you can see in the background there's a support system, a bracing system, and there are some horizontal braces that also will be installed to brace the center section of the panel array as well. So some benefits of a house mount: it's typically close to the power destination, right on the roof. The batteries could be inside. Some batteries have a temperature factor that is important in their power output and longevity. Lead acid batteries need to be warmer. Lithium ion shouldn't be used below 0 or in teens types of temperatures because they lose power significantly, but they are more resilient in charging factors and deep cycling than lead acid batteries. The porch mount, in the particular case of the grid tie system that was shown here, benefits the fact that there's no EMF potential from the panel array itself. After doing research, there's very minimal with a roof-mounted EMF system from the panels themselves. The EMF issues come from the smart meters that are installed to communicate with the power grid about production. So you'd want to create or produce or purchase a shield, a Faraday cage shield for the smart meter to reduce your EMF exposure from that. Some downsides of a house mount: again, the smart meter produces dirty electromagnetic fields. Choose analog if you have the option to do that. That would be best. Requires a meter reader, but it also prevents you from having electromagnetic radiation exposure. Solar power itself can be dirty, but filters can be installed in the house to help minimize that. And also a pure sine wave inverter can definitely make a difference in that, because much of the dirty power comes from the modified sine wave production of a cheaper inverter. So look for a pure sine wave inverter. On the house, if it gets covered with snow, it definitely reduces your power output. If they need to be cleaned because they're not as pitched as the rack array, they're not as easy to clean. Also, a downside is that they're tied to the grid, and if you have no power from the grid, you have no power from the solar because they're integrally tied in, and there's no batteries associated with it. So having no batteries can be a pro and it can be a con depending on your situation. A rack mount, some benefits of a rack mount: it can provide additional coverage area. In addition to additional panels, it also can produce storage sites that are available. They're easy to clean and easy to remove snow from the ground level without having to climb up on a ladder system in the wintertime or anything like that. They're steep enough to shed most snow, and they easily get washed with the rain and maximize the sun exposure through the season, especially with a direct south-facing application. In the particular site that we looked at, the power cable ran to the home from the rack site underground, and the inverter battery and charge controller system was at the rack site, at the solar system array site, to transmit the power or convert the power to AC for better voltage transmission down the line to the home site, which is all underground. The downsides, it's an additional build, although it's not complicated and are from readily available materials. The cables run underground from the rack site, which could be a benefit because you don't have above ground transmission lines, but it does require a dig to put those in. The battery power controller and charge controllers, again, are at this rack site, so the potential for temperature effects on the battery system itself and the attenuation of the power output is a potential. So the equipment is remote from the power destination, which could be construed as a con, particularly if you have lead acid batteries and you're having to do routine maintenance. It just is an extra place to go rather than having them conveniently located in your house. But there are benefits and downsides to both application, and both applications work very well.
Installation number 1 is a full house grid-tied system. This solar system was professionally designed and installed and is grid-tied only, so it has no batteries, and it uses a two-way meter to do net metering with the power company. Here's a picture of the panels, which in this case are mounted on the roof of a shop building. And this is an aerial shot showing that it has 20 solar panels on the roof. This is what a two-way power meter looks like, allowing them to do net metering with the power company. So they can sell power to the grid, and then they can buy power back as needed. Installation number 2 is a grid-tied system, but in this case it's for a church, and so it was the roof for shade for a covered parking area in Arizona. This was professionally designed and installed and is grid tied only. Here's an aerial view of the church property. You can see in the lower right corner of this image there are the panels. There are lots of them, enough for a half a dozen or more parking spots. And here is what the structure looks like that holds the solar panels, and the shaded parking that is available looks like on both sides of this structure. This is also in Arizona. This is a grid-tied whole house system. It was professionally designed and installed. And you can see on the roof that there are 18 roof-mounted solar panels. This is the equipment. There's your net metering two-way meter and other controls for managing the system. Again, because this is grid tied, it doesn't have batteries. Installation number 4 is a house grid tied project. In this case, the owner of the house designed it and did the installation, and it is whole house. It is grid tied. He is planning to add off-grid option with batteries and charge controllers, but the pictures that I have at the moment are a grid-tied system. Once this system has been added to with the off-grid option, it will then be a hybrid because it can go both ways. He can sell back to the grid and provide power when the grid is down. So here these particular hardware pieces are used on an existing 3-tab shingle roof to be able to build mounts in a waterproof fashion, and you can see them in the roof already installed. And here the rails have been added to the roof, mounting hardware on which the solar panels will be mounted. And here are the solar panels being mounted. There are 12 Trina brand panels that are 315 watts each. So the total system is 3.8 kilowatts of potential power. This is the fastener that's used to hook the rail to the solar panel. You can see it just goes between the panels and pinches down on the rim of the solar panel. Nice and neat and professional. So here the first 5 panels have been installed. Very nicely done. And the wiring from the panels go through this waterproof contact point through the roof. On the inside, this particular installation was convenient because above the garage was designed so that there's a little attic room up there. The trusses were built in such a way that there is a room above the garage and a drop-down ladder. So this room is where all of the electronics are mounted for this system. And conveniently, you can see there's light coming in from the left. So there's a window in a dormer above this section of the roof where the panels are, and it happens to go right into this little room. So the individual can open the window and climb out on the roof. Pretty handy. So this is a Sunny Boy inverter. You will recall from the Part 28 session on solar that Sunny Boy is one inverter that does allow a grid-tied system to have the ability to pull some power when there is no power but there's sunlight. So this individual has a Sunny Boy inverter. This is what the inside of the inverter looks like. Here it is with the cover on and the wiring almost complete. And here it is complete. The Sunny Boy is wired, and again, soon he's going to have charge controllers and lithium batteries that will make it grid-tied as well as off-grid capable. Installation number 5 is an RV off-grid project. This is owner installed, and it's a whole RV system, and it's off-grid. So it has 6 Trina 315 watt panels on the roof with a total of 2 kilowatts of potential power. By the way, you'll notice when it's on the roof of an RV, it's basically horizontal. So there isn't the option to angle it to get the most potential from the angle of the sun, but it still works. It just doesn't work quite as good as if you had them positioned to face the sun directly. Here's the wiring connections inside, nice and neat. And these are the charge controllers. There are 3 of them. Charge controllers, again, maintain the battery voltage from the sun so you don't overcharge the batteries. And because the panels, there's 6 panels, because they were put in pairs, each charge controller does 2 panels. And here's the inverter. It's a 3,000 watt pure sine wave inverter. You will recall from session 28 that pure sine wave is what you want. You don't want to have modified sine wave because some things won't work with that. So pure sine wave is the preference. The batteries are in a box. They're lithium batteries. They're stored with the inverter and charge controllers under the floor of the RV in the basement storage area. Installation number 6 is a house, full house off-grid system. This is owner designed and installed. Does not sell back to the grid by choice. Can run the whole house in good weather. Will be expanded with more panels and batteries, attempting to service the whole house year-round. These are roof-mounted panels as compared to being on a rack. So here is the first stage of the solar panels installed. There are 18 panels, 330 watts each. Total potential power is 5.9 kilowatts. This individual plans to add more panels on that roof and pretty close to double his potential. These are 34 lithium batteries that were salvaged from a wrecked Nissan Leaf. It's a really good way to go. Nice and neat, compact lithium batteries. They're 8 years old, but they should last a long time. Installation number 7 is an off-grid water pump. This is owner designed and installed and provides water for the house supplied using off-grid solar power. So it has 4 panels, 330 watts each, with a total of 1.3 kilowatts. And it has a midnight charge controller, an inverter, and a breaker panel, and uses a lead acid deep cycle battery like you might get from Costco. and it uses a large size RV 12-volt water pump. If you have any experience with an RV, when you turn the faucet on, you'll hear it like that. That's the water pump running on demand as their pressure is needed. Excuse me. So that's the kind of pump that's running this. Now, this is not pulling water out of a well. This is pulling it out of large tanks that are below the house, but not very far below the house. And it does a very good job of providing ample water pressure in the house. Installation number 8 is a well pump that's solar backup. So this person has grid power and is concerned when there's a power failure that he wouldn't be able to have water to the house. So this was professionally designed and installed. It provides emergency power during power failures for the well pump and the house pump pressure pump. It has 2 pumps. It has a pump to pull the water out of the ground, which is a deep well, and then there's a pump to push it from the tank into the house. So it has 2 pumps, pretty good sized pumps. So here are the panels on the roof. There are 4 250-watt solar panels mounted on the building in which the equipment is. That's a total potential of 1 kilowatt. The pump house, you can see, is nice and neat. It's got the inverter up above. It's a big inverter because it has to do 220 volts for the water pumps. The charge controller is the black item in the middle, breaker box on the left, and at the bottom, the diamond plate box is the battery bank, and the blue items have to do with filtering and stuff for the pump. The pump is actually, one of the pumps is on the lower right in blue. So this is a close-up of the inverter. This is a big inverter because, like I say, it's going to run 2 pumps at 220 volts. And the charge controller and breaker panels are in this view. It has a battery bank with 8 lead-acid deep cycle batteries from Costco. So each battery is 12 volts times 8. Okay, the battery box, custom made aluminum diamond plate box with an opening lid. Keeps it nice and neat. Installation number 9 is an off-grid house system. This was owner designed and installed. All critical load household electrical is off-grid. Now, just so you understand, critical load are the items that you would want to make sure you could have if there was a power failure. And non-essential items, in this case, are on the grid. So, for instance, if you were roughing it and there was a long-term power outage for whatever reason, the house would use a wood stove. So you wouldn't need the ovens, the electric ovens. So the items that are non-essential that are on the grid are heat generating electrical items that you would have an alternative for if you had to through the wood stove. In this system, it is not sold back to the grid by owner's choice. So here's a picture of the solar panels. There's 42 panels, 250 watts apiece, so there's 10.5 kilowatts of power. It's on a home-built, custom-built rack rather than being on a roof. And the angle is the difference between a winter sunlight angle and a summer sunlight angle. So it's 45 degrees, and that varies from location to location, in case you're wondering. And this rack was made, in an effort to be economical, was made out of components from Home Depot for building chain link fences. The piping, the rails, the braces, and all that are chain link components. The rails that the solar panels are mounted on are unistrut, like electricians use in industrial applications. And to connect the unistrut and the round pipe, there were exhaust pipe clamps to do that. Because there are 42 panels, it's 2 complete arrays of solar panels. And so there's 2 combiner boxes, which are basically breaker boxes with each panel having its own breaker. And then those all connect together in each combiner box and send the wires to the power control area. So this is two complete solar setups with two complete sets of wires going to where the batteries are. So now we're in the garage, and the power is coming in with the double pipes. That's another set of breakers. And then because it's two sets, there are two charge controllers. Again, charge controllers maintain the battery level. The white box is a 48 volt, 680 watt power inverter that will make 110 volt and 220 volts for the house. So everything in the house that's critical load, which is most everything, is running off the inverter, off grid. And therefore it has batteries, and the batteries are stored in Rubbermaid deck boxes like you would buy at Home Depot. The batteries are 24 forklift batteries. They're lead acid. They're 22 volts apiece, so that's a 48 volt system. Number 10, installation is a low budget emergency solar. So what I'm going to show you now is a thing you can buy off the shelf, and out of the box it can work. So for under $200 at Harbor Freight, you can buy a 100-watt solar panel package. It comes with the solar panels, it comes with a variety connections and so forth, some lights, a stand. You could use it if you were camping. You could take it with you if you were doing a tiny house. 100 watts is not a lot of power, but it can charge cell phones and run some small components if you had a battery. So here's another view. It has four 25-watt panels, the mounting hardware, a charge controller, a 12-volt lighting kit, a DC power adapter for plugging in things like a cell phone, a USB port for charging devices. Again, that's $199, and those are the components that you get. Now, I would suggest if you did that, you would add an inverter so that you could plug in, say, a television or something like that. That's running 110 volts. And this inverter is $25 at Harbor Freight, and it'll do 400 watts. Then you would need to have a battery, and you can buy one of those from Harbor Freight or Costco. This one is a 12 volt, 35 amp hours for $73. So if you bought all those together for under $300, you'd have a 100-watt solar array that's portable, and an inverter and a battery. The last item is even cheaper. This is an extremely low budget emergency solar setup. It's out of the box, it's from Harbor Freight, and it really is low power. Here's the panel. It's 7 watts. To give you a perspective, the vehicles that I have, during the winter when I'm not using them, I have what's called a trickle charger, or a battery maintainer is another variation of that. And that runs about 2 watts. And that will maintain a battery that's already fully charged. 7 watts would probably not charge from low to full a deep cycle battery like an RV battery. If it did, it would take a very long time. And keep in mind, this is 7 watts when the sun is in perfect alignment and there's no clouds, and it isn't going to do it in the middle of the night. So for $33, you could charge your cell phone or something like that, but it's very minimal, and it's just an emergency deal. So solar system variations to consider based on what we've seen. You can roof mount or you can rack mount. In this particular picture, this is a pole mount, and that's not as popular as it used to be. A pole mount system adjusts the angle left to right throughout the day to follow the sun. Has a motor and a sensor. Solar power or solar equipment, solar panels have got so cheap compared to what they used to be that it's now mostly considered the most effective way is to not burn up the energy to run a motor to pivot this thing, but just make more panels. So they can be roof mounted or rack mounted. You can either build it yourself, or you can have it professionally built, or it can be grid tied or off grid. And that concludes our tour of different options for installations for solar alternative energy.